Listen closely. Can you hear it? The faint rhythmic pulse that defines existence. From the smallest cell to the grandest galaxy, life moves to a beat. We often believe our world, this verdant sphere, dances to a steady, predictable drum. We assume its warmth, its blue oceans, its distant polar caps are the unwavering norm. But beneath the familiar surface, in the deep quiet of geologic time, another rhythm plays. A vast, silent pulse that governs our very existence, yet remains unseen by human eyes. It is the slow, cosmic breath of a planet that has spent ages in deep slumber, only to stir briefly, offering us this fleeting warmth. We are living in a moment that is less a rule and more a whispered pause. Tonight we will listen for that deeper beat, the one that tells the true story of our world. For the tapestry of Earth's past reveals a striking truth. The gentle climate we cherish today, the stable warmth that allowed agriculture to bloom and cities to rise, is not the planet's default state. It is a rare, delicate anomaly, an interlude. Zoom out across the last million years, and the vibrant greens and blues would fade, replaced by an overwhelming expanse of white. This planet, our home, has spent the vast majority of human history shrouded in ice. Titanic sheets 3 kilometers high did not merely cling to distant poles, they marched. Across North America, Europe and Asia, they buried entire continents, grinding mountains to dust. The age of ice, therefore, is not a forgotten chapter. It is merely sleeping. The glaciers have not vanished entirely. They have simply retreated like watchful giants, withdrawing into the shadows of the Arctic and Antarctic, awaiting a hidden signal to return. Before you truly settle in and let yourself relax, take a brief moment to show your support by liking the video and subscribing only if what you find here genuinely resonates with you. You're also welcome to leave a comment sharing where you're listening from and what time it is for you. It's always quietly fascinating to see this journey being shared by people across the world. Now lower the lights, perhaps switch on a fan to create a soft, steady background hum. And let's gently ease into tonight's journey together. Tonight we seek that signal. We search for a rhythm, a profound pattern embedded in the fabric of time, one so immense it eludes the fleeting human lifespan, yet powerful enough to orchestrate the rise and fall of global oceans. Every 100,000 years, like a cosmic heart drawing a slow, deep breath, our Earth freezes, and then with an equally predictable grace it thaws. This is the profound mystery of the Milankovitch cycles. It is the quiet symphony of celestial mechanics, a story of how the subtle dance of our planet through the darkness of space determines the fate of every living thing upon its surface. It is a tale of precise mathematics, of gravitational whispers, and of a solitary prisoner who deciphered the riddle of the ice, while the world outside his window was consumed by the fires of war. We will trace the intricate gears of this great cosmic clock. We will stand in imagination upon the ice sheets that once crushed continents. We will look to the heavens and understand why a slight inclination, a gentle tremor in our planet's spin, possesses the power to transform a verdant garden into a desolate wasteland. To discern the ancient rhythms of the past, we must journey to the quietest, most desolate place on Earth. We must travel to the heart of the Antarctic plateau, to the remote Russian research outpost of Vostok. Here, temperatures plunge to a searing 89 degrees Celsius, a cold so absolute that human breath crystallizes, instantly falling to the ground like frozen dust. It is a white, featureless void, an expanse of monochrome stillness that stretches endlessly in every direction. Yet Vostok's true treasure lies not on its unforgiving surface, but in the silent depths beneath. Under the boots of the dedicated scientist lies a sheet of ice nearly 4 kilometers thick. This isn't just ice, it is a profound library. Snow in Antarctica, unlike elsewhere, rarely melts. It falls year after year, accumulating in successive undisturbed layers. As new snow blankets the old, its immense weight compacts it, squeezing the fluffy white powder into hard blue translucent rock. This transformative process captures something invaluable: As the snow solidifies into ice, it seals off tiny pockets of ancient air between its crystals. These become microscopic time capsules, pristine samples of Earth's atmosphere from the precise moment each snowflake fell. Drill down a mere 100 meters and you breathe the air from the age of Roman empires, plunge a kilometer deeper and you inhale the atmosphere from a time before human civilization even flickered into existence. At Vostok, they drilled deeper still. For decades, under conditions that pushed the very limits of human endurance and ingenuity, teams of scientists bored a shaft straight into the heart of this colossal ice sheet. They retrieved cylinders of ice known as ice cores, some stretching over 3,000 meters long. When examined in a sterile laboratory, these cores resemble long, polished glass cylinders, but look closely and you perceive the millions of tiny suspended bubbles. These bubbles are the fossilized breath of the planet itself. They hold the ancient carbon dioxide, the methane and the dust of worlds that have long since passed. By carefully crushing these samples in a vacuum chamber and analysing the liberated gases, we can literally taste the air of the deep past. The original Vostok core transported us back 400,000 years. Subsequent cores, such as those from Dome C, extended this journey even further, revealing an atmospheric record stretching back 800,000 years. It stands as the most complete, continuous and high-resolution climate record ever recovered. It is a vertical timeline perfectly preserved in the deep freeze, untouched by decay, unmarred by erosion, patiently waiting for humanity to learn its language. And when scientists finally laid out the raw data from these extraordinary cores, when they meticulously plotted the temperature fluctuations alongside the carbon dioxide levels over nearly 1 million years, they saw neither a random line nor utter chaos. They saw a heartbeat. The data from Vostok was not ambiguous. Its clarity was startling. When the temperature of the Earth over the last 800,000 years was graphically represented, the line did not meander aimlessly. It bore no resemblance to the random chaotic fluctuations of daily weather. Instead, it moved with the precision of a machine. The graph formed a perfect repeating and sharply serrated shape. We call it the sawtooth. Imagine the teeth of a massive saw blade. One side of each tooth is long and gradual, a slow descent. The other side is short and exceptionally steep. The long, gradual slope represents the inexorable freeze. For approximately 90,000 years, the Earth slowly, relentlessly grew colder. The vast ice sheets expanded bit by bit, century after century, consuming continents with their white embrace. Global temperatures slid steadily downward, plunging into the depths of a glacial maximum. And then the sudden dramatic break. The steep vertical side of the tooth. In what is geologically speaking a mere blink of an eye, perhaps only 10,000 years, the temperature rocketed upward. The titanic ice sheets collapsed with terrifying speed. The world flooded. The climate snapped from a deep frozen grip to a warm, stable interglacial period, a period precisely like the one we inhabit today. And then almost immediately the slow chilling slide back into the cold began anew. This profound pattern repeats again and again 8 times in the last 800,000 years. Every 100,000 years the planet inhales the cold and then briefly exhales the warmth. It is a rhythm as steady and precise as a cosmic metronome. It is a heartbeat. This astonishing discovery fundamentally altered our understanding. It revealed that the ice ages were not mere accidents. They were not the result of random volcanic eruptions or stray asteroid impacts. They were cyclical. They were inevitable. Something was driving this immense cycle. Something powerful enough to freeze an entire planet, yet precise enough to do so on a schedule that one could literally set a clock by. But the source of this profound rhythm was not found on the Earth itself. You cannot find a 100,000-year cycle in the shifting tectonic plates. You cannot find it within the swirling ocean currents. The Earth, by its internal mechanisms, is a chaotic place. It does not keep time with such meticulous regularity. To find the true clockmaker, we had to look entirely away from our planet. We had to wait for a Serbian mathematician confined to a prison cell watching the flickering light of a candle to realise that the answer lay in the silent mathematical perfection of the sky. The answer to the profound riddle of the ice did not emerge from a glaciologist standing atop a frozen peak. It came from a mathematician sitting in a prison cell. The year is 1914. The world outside is rapidly descending into the unfathomable chaos of the First World War. While armies mobilise and empires crumble into dust, a brilliant Serbian engineer and mathematician named Milankovitch is arrested by Austro-Hungarian authorities. Detained as an enemy alien torn from his honeymoon, he's eventually confined in Budapest. But while the world outside his window tore itself apart with artillery and mustard gas, Milankovitch performed an act of extraordinary intellectual courage. He turned his back on the chaos of the immediate present and looked deep into the profound silence of the cosmic past. He was granted a small, unexpected mercy. He was permitted to work within the hallowed quiet of the Hungarian Academy of Sciences library. He sat there day after day as Europe burned, armed with nothing but a fountain pen, stacks of paper and a slide rule. He set himself a task that even today seems almost impossibly audacious. He decided to calculate the Earth's climate for the preceding 600,000 years. He possessed no ice cores. He had no supercomputers. He lacked the vast geological data we now possess. He had only the timeless laws of physics and the celestial ballet of the cosmos. Milankovitch firmly believed that the Earth's climate system was not a random, unpredictable phenomenon. He understood it as a vast machine meticulously driven by the immense energy of the sun. And if it was a machine, its movements, its cycles could be calculated with mathematical precision. He reasoned that if he could precisely map the Earth's exact position relative to the sun for every single point in the deep past, he could then determine precisely how much solar energy fell upon the planet at any given latitude. It was a calculation of staggering, almost unimaginable complexity. He had to account for the gravitational pull of distant Jupiter and Saturn, the subtle shifting mass of the Earth itself, and the intricate clockwork interactions of the entire solar system. He worked in profound solitude for years. He filled thousands of pages with dense handwritten trigonometric equations. He mentally lifted the Earth out of its orbit and spun it backward through the vastness of time. He was constructing a mathematical ghost of the planet. And as the numbers began to align, as the pages filled with his elegant script, a profound pattern began to emerge from the ink. It was not a chaotic scrawl, it was a wave. Milankovitch realized that the Earth does not travel through an empty void. It travels through an intricate web of invisible forces, and these forces, these gravitational tugs from distant planetary giants, were slowly, rhythmically altering the very way our planet moves. He had found the gears of the great cosmic clock. Before Milankovitch, geology was almost exclusively a science of looking down. When scientists pondered why the climate changed, they sought answers deep within the Earth itself. They looked to volcanoes, to the slow ballet of shifting continents, to the vast circulation of the deep oceans. They assumed that the fundamental causes of Earth's climate history were contained entirely within the Earth. They treated the planet as a closed system, a lonely vessel drifting through an indifferent void. Milankovitch, with his quiet calculations, shattered this illusion. He realized that to truly understand the fevers and chills of our planet, you cannot merely observe the patient. You must also understand the vast, intricate room the patient stands within. He understood that Earth is not a closed system. It is powered by a single colossal external engine, the sun. Every scintilla of energy that propels the wind, sculpts the rivers, and nurtures the forests originates from that distant star. Therefore, the temperature of our Earth is determined by a deceptively simple equation. How much sunlight do we receive, and where precisely does it fall upon our globe? For a long time, it was assumed this relationship was constant. The sun burns steadily. The Earth circles it in an unchanging path. The seasons arrive and depart with predictable regularity. But Milankovitch identified the profound flaw in this static picture. He realized that the solar system is not a solitary, isolated place. It is a crowded, dynamic room. We share this immense space with giants Jupiter and Saturn, colossal gas behemoths with gravitational fields so immense they dwarf our own, and we share it with smaller rocky neighbours like Venus and Mars. gravity is an invisible tether. It is weak, yes, but it is infinite. It reaches across the vacuum of space, never truly diminishing to nothingness. And so, as the Earth traces its annual journey around the Sun, it is not following a perfect isolated line. It is being pushed. It is being pulled. It is being nudged by the gravitational might of Jupiter, subtly tugged by the sheer mass of Saturn. These forces are incredibly subtle. In a single year, their effect amounts to almost nothing discernible. But time profound and patient is the ultimate magnifier. Over tens of thousands of years, these tiny rhythmic gravitational tugs accumulate. They begin to subtly warp the very path of our planet. They begin to tilt its axis. They begin to make it wobble. Milankovitch realised that the Earth's precise position in space is not fixed. It is engaged in a complex, ceaseless dance. And this cosmic dance fundamentally changes the way sunlight strikes the Earth's surface. It doesn't necessarily alter the total amount of heat our planet receives. Rather, it changes precisely where that heat lands and, crucially, when. He meticulously identified 3 distinct movements, 3 different gears within this cosmic clock. Each runs at its own unique speed. Each affects the climate of our world in its own profound way. When these gears align in a rare synchronous embrace, they possess the power to turn the Arctic sun away to allow the delicate winter snow to survive the brief summer and eventually to bury the world in vast sheets of ice. We often perceive the solar system as a pristine, utterly orderly machine, a perfect model of clockwork precision, where planets roll along invisible tracks, isolated and indifferent to one another. But gravity is a force that respects no boundaries. It is infinite. While it weakens with distance, it never truly disappears. In the black silence of space, the Earth is far from alone. It is surrounded by distant, powerful giants. Far beyond the orbit of Mars lies Jupiter. This is a planet so incredibly massive that it contains more than twice the material of all the other planets in our solar system combined. It is a failed star, a colossal sphere of gas with a gravitational field that reaches out across hundreds of millions of miles. Beyond it lies Saturn, another ringed Titan, whose immense pull further influences the solar system's delicate balance. As the Earth races around the Sun at an astonishing 67,000 miles per hour, it is constantly passing through the gravitational wake of these colossal giants. Every time we sweep past Jupiter, we feel a subtle tug. It is an almost imperceptible lurch, a gravitational whisper in the cosmic void. If this happened just once, it would mean nothing. But it happens again and again, ceaselessly, for billions of years. It is akin to pushing a child on a swing. A single gentle push does very little. But if you push at precisely the right moment every single time, the swing returns, that energy accumulates. The arc of the swing grows higher. The movement becomes dramatically exaggerated. This is the profound principle of orbital resonance. Because of these constant rhythmic tugs from Jupiter and Saturn, the Earth's path through space is not perfectly stable. It is flexible. It breathes. Our orbit stretches out slowly, becoming more elongated and elliptical, occasionally pulling us millions of miles further from the life-giving warmth of the Sun. Then, just as slowly under the influence of different alignments, it is squeezed back into a near-perfect circle. The Earth itself spins like a massive top, but under the persistent gravitational pull of the Moon, and the Sun at top begins to gently wobble. Its axis nods gracefully up and down, a slow, hypnotic oscillation relative to its orbital plane. This is the cosmic clockwork. It is a complex, beautifully chaotic dance of gravity. The Earth is continually being passed back and forth, a small rocky vessel caught in a gravitational tide between the immense pull of the Sun and the distant gas giants. And Milankovitch realised that this intricate dance can be broken down into 3 distinct movements, 3 specific gears that collectively drive the profound climate cycles of our world. The first of these gears is the largest, the slowest, and in its ultimate effect the most powerful. It is the very shape of our orbital path itself. The first gear of the cosmic clock is indeed the slowest, yet it is the profound rhythm that sets the tempo for the entire Ice Age cycle. It is called eccentricity. In our minds and in the simplified diagrams we often encounter in school, the Earth's orbit around the Sun is almost invariably drawn as a perfect circle, a stable, unchanging ring. But this is a profound simplification. The true path of the Earth is not a circle. It is an ellipse. It is an oval like a circle that has been gently, subtly flattened. And this shape is not fixed. It breathes. Over a vast patient cycle of roughly 100,000 years, the immense gravity of Jupiter and Saturn slowly, persistently pulls on the Earth. They subtly stretch our orbit. The path transforms from a near-perfect circle into a long, elongated oval. And then just as slowly it snaps back, returning to a more circular form. This is the stretch. Why does this subtle change matter so profoundly? Because an orbit is not merely a line in space. It is a fundamental measure of distance. When the orbit is more circular, the Earth maintains a relatively constant, comfortable distance from the Sun throughout the entire year. The solar heat is steady, predictable. But when the orbit stretches, when eccentricity is high, the Earth is compelled to travel much further out into the cold, dark reaches of space, before eventually swinging back in toward the Sun. At the furthest point of this long oval known as aphelion, we are millions of miles farther away from the Sun than usual. It is the difference between standing directly next to a roaring fire and taking 2 significant steps back. The total amount of solar energy reaching the entire planet drops measurably. The winters become fractionally longer. The summers become subtly weaker. The planet receives less overall fuel to sustain its warmth. And here is the profound key this cycle. This slow stretching and relaxing of our orbit takes precisely 100,000 years to complete. This period matches with astonishing accuracy the heartbeat we observed in the ancient ice cores. The distinctive sawtooth graph from Vostok. The grand rise and fall of the colossal ice sheets beats in perfect synchronization with the stretching and contracting of our orbit. When the Earth is pulled far from the Sun, the ice grows. When the orbit becomes circular once more, the ice recedes. This is the primary rhythm. The 100,000-year pulse of the ice ages is quite literally a mathematical map of our fluctuating distance from the life-giving star that warms us. Yet distance alone is not sufficient to fully freeze a planet. The cold requires assistance. It needs to know precisely where to strike, and for that we need the second gear. The first gear, eccentricity, dictates how far we stand from the cosmic fire, but the second gear dictates something far more subtle, and in its implications far more dangerous. It dictates the precise angle at which the Sun's light strikes our planetary face. This is obliquity, the tilt. To truly grasp this, you must envision the Earth not as a static globe resting on a desk, but as a vast spinning top. When a top spins rapidly, it maintains a perfectly upright posture, but as its speed diminishes or as it is gently nudged by invisible forces, it begins to nod. It rocks slowly back and forth, a mesmerizing hypnotic oscillation relative to the unseen floor. Our planet is that top. It is spinning at an incredible 1,000 miles per hour, suspended in the silent vacuum of space, and it is nodding. We're universally taught that the Earth is tilted at 23.5 degrees relative to its orbital plane around the Sun. This is the magic angle. It is the fundamental reason we experience seasons. When the northern hemisphere tilts toward the Sun, we experience the warmth of summer. When it tilts away, we endure the chill of winter. It is the powerful engine of our yearly calendar. But this number 23.5 is not a fixed constant. It is merely the angle at which we find ourselves right now. Over a cycle of approximately 41,000 years, the Earth slowly rocks back and forth. This angle changes, shifting from a shallow 22.1 degrees to a steeper 24.5 degrees. On the surface, it seems like a trivial difference, a mere shift of just 2 degrees. On a protractor, it is barely perceptible. But on the scale of a planet, it is the profound difference between a thriving garden and a crushing glacier. This brings us to the great paradox of the ice ages. If you were to ask someone what causes an ice age, they would most likely respond with very cold winters. It makes intuitive sense. If the winter is brutal, the world freezes. But Milankovitch, with his deep understanding, realized this intuition was fundamentally flawed. He grasped a profound meteorological truth: truly cold, harsh winters do not in fact build massive glaciers. On the contrary, extremely cold winters are often characterized by dry air and minimal precipitation. They effectively starve the nascent ice sheets of the moisture they need to grow. The true architect of an ice age is not the winter, it is summer. Consider the precise mechanics of a glacier. A glacier is born from accumulated snow. Every winter, fresh snow falls upon the high northern latitudes of Canada, Scandinavia, and Siberia. This is normal, predictable. The critical moment, the hinge of fate, arrives in July. When summer arrives, its essential task is to melt that accumulated snow. It must wipe the slate clean, so to speak, before the next winter arrives with its fresh snowfall. If the summer is hot and intense, the snow vanishes and the land remains green and fertile. But what happens when the Earth's tilt is low? What happens when the angle of obliquity is shallow at its minimum of 22.1 degrees? It means the summer sun does not climb as high in the sky. It stays lower on the horizon. Its rays are weaker, more slanted and significantly diluted by the greater atmospheric path they must traverse. It offers light, yes, but very little concentrated heat. In this critical scenario, the summer fails in its primary duty. The sun shines, but it is simply too weak, too oblique to fully melt the previous winter's snow. The snow survives. It lingers stubbornly through June, through July, through August. It sits on the ground, persistent and white, tirelessly, reflecting the weak summer sunlight straight back into space. And then September arrives. The next winter begins. Fresh snow falls on top of the old unmelted snow. This then is the fragile seed of an ice age. It is a simple residue of winter that the summer was too weak to erase. Year after year, this leftover snow accumulates. The sheer weight of the new layers presses down inexorably on the old. The delicate snowflakes are crushed. They lose their trapped air. They transform from fluffy white powder into a granular, denser substance called firn. And then under immense crushing pressure, they fuse into solid, impenetrable blue ice. This process repeats over and over again for thousands of years. The pile grows ever higher. It begins to flow under its own immense weight, like a slow-motion river of solid rock. It swallows valleys whole. It overtops mountains. This is the profound power of the tilt. It is the 41,000-year cycle that precisely controls the strength of the seasons. When the tilt is high, the seasons are extreme, producing hot summers that destroy the ice. When the tilt is low, the seasons are milder, with cool summers that allow the ice to survive and expand. This gear, this gentle rocking of the planetary cradle, ultimately determines whether the snow melts away, or whether it gradually builds a towering monument to the cold. But there is one final gear, a gear that is faster, stranger, and often more chaotic than the others. A subtle wobble that changes not just the seasons, but profoundly the very stars themselves. The first gear stretches the orbit a slow, deep breath. The second gear rocks the axis a patient nod. But the third gear is the most disorienting of all, for it subtly changes the very definition of our place in the cosmic tapestry of stars. This is precession, the wobble. If you have ever observed a spinning top closely, you know that it does not merely remain perfectly upright. As it spins, the handle at its apex traces a slow, lazy circle in the air. It precesses. The Earth is doing precisely this. Right now, our North Pole points directly, faithfully at a specific star, Polaris, the North Star. It serves as our celestial anchor, the fixed point by which sailors have navigated for thousands of years, a beacon of assumed permanence. Yet it is not permanent. Because of the incessant gravitational pull of the Sun and the Moon ceaselessly tugging on the Earth's bulging equator, our planet's axis is slowly, imperceptibly twisting. The North Pole is tracing a massive patient circle in the vast dome of the night sky. 12,000 years ago, our ancestors did not gaze up at Polaris. They look to a brilliant blue-white star called Vega to find their north. In another 12,000 years, our descendants will once again look up and behold Vega as their North Star. Polaris will simply become another random star in the cosmic drift. This entire cycle, this grand celestial ballet, takes roughly 23,000 years to complete. It is the fastest hand on the immense cosmic clock. But why, one might ask, does the precise direction of our axis matter so profoundly for Earth's climate? Why does it matter which distant star we happen to point towards? It matters critically because the Earth's orbit is not in fact a perfect circle. Remember the first gear, the stretch? The Earth has a specific point in its elongated orbit where it is closest to the Sun, known as perihelion, and a corresponding point where it is furthest away, aphelion. Precession determines which season falls on which side of this elliptical orbit. This timing is absolutely critical. Right now, by a remarkable stroke of cosmic luck, the Northern Hemisphere experiences its winter when the Earth is closest to the Sun. This fortunate alignment makes our winters slightly milder than they might otherwise be. We are closer to the roaring cosmic fire during our coldest months, but the wobble is turning. In approximately 10,000 years, the axis will have flipped its orientation relative to the orbit. The Northern Hemisphere will then experience its winter when the Earth is at its furthest point from the Sun, deep in the cold, dark reaches of space. Conversely, it will experience its summer when it's closest to the intense roaring heat of the star. This creates a powerful cycle of extremes. When precession aligns perfectly with eccentricity, it can create what we might call a super season. It can make winters brutally cold and relentlessly long, while simultaneously making summers intensely hot and short. Or as the cycle turns, it can do the precise opposite. It can create mild, forgiving winters and crucially cool, ineffective summers. And as we have learned, cool summers are the decisive key. When the wobble aligns just right, it positions the Northern Hemisphere particularly where the great land masses of Canada and Siberia lie to receive the absolute minimum amount of summer solar energy. It effectively robs the summer of its power to melt the accumulated snow. This is the third gear. It is the fine tuner. It is the frequency modulator that either amplifies or cancels out the subtle effects of the other two gears. Milankovitch now possessed all the intricate pieces. He had the stretch operating on a 100,000-year cycle. He had the tilt with its 41,000-year rhythm, and he had the wobble, the 23,000-year precession. Separately, these are merely gentle nudges, cosmic whispers in the void. But Milankovitch realised that these cycles do not act in isolation. They overlap. They weave together into an intricate celestial tapestry. And every so often, like the tumblers of a giant cosmic lock clicking into place, they all align in the same profound direction. And when they do, they open the door to the ice. Individually, these forces are weak. A slightly stretched orbit might change the incoming sunlight by only a fraction of a percent. A lower tilt might cool the summer by a mere degree. A wobble might shift the calendar by just a few weeks. On their own, they are nothing more than background noise in the solar system. But Milankovitch realised that time is a master weaver. It takes these separate threads, the 100,000-year stretch, the 41,000-year tilt, and the 23,000-year wobble, and it braids them together. Most of the time, these cycles work against each other. The orbit might be slowly pulling us further from the Sun, but the tilt might be high, giving us intensely hot summers that melt any nascent ice. They effectively cancel each other out. The climate remains relatively stable. The planet remains green and hospitable. But once every 100,000 years, with astonishing precision, the gears align. The tumblers of the great cosmic lock click into place. It is a moment of profound constructive interference, a perfect storm of sustained cold. Imagine the precise scenario. First eccentricity reaches its absolute maximum. The Earth's orbit is stretched into its longest, thinnest oval. We are pulled millions of miles away from the intense furnace of the Sun. Second precession turns the axis. It dictates that the Northern Hemisphere experiences its brief summer at the exact moment the Earth is at that furthest coldest point of the oval. The summer sun is distant, small and weak. Third obliquity drops to its minimum. The Earth stands nearly upright. The tilt decreases to its shallowest angle, meaning that distant, weak summer sun strikes the high latitudes at an even shallower glancing angle. It is a devastating triple blow. Distance, timing and angle all conspire with cruel efficiency to rob the northern continents of their vital summer heat. The crucial solar energy falling on the critical skylights of the Arctic places, like the Canadian Arctic or the Scandinavian Highlands, drops precipitously. It falls below the critical threshold. The snow that falls so abundantly in winter simply does not melt in summer. It survives. It waits for the next winter, and the next a slow, relentless accumulation. Milankovitch sat in his cell and calculated these intricate curves by hand. He drew a graph that predicted exactly when these moments of perfect alignment occurred in the past. He predicted the very timing of the ice ages before anyone had ever drilled an ice core or sampled ancient air. He saw the mathematical inevitability of the cold, yet there was still a problem, a nagging gap in the theory that haunted him. When one performs the precise mathematical calculations, even this perfect storm of orbital alignment only reduces the total incoming sunlight by a relatively small amount. It is a significant drop, yes, but on paper it is not by itself enough to freeze an entire planet. It is not enough to build ice sheets 3 kilometers thick. The mathematics suggested the Earth should merely get slightly cooler. The geological evidence, however, screamed that the Earth had been transformed into a frozen, desolate wasteland. There was a missing piece. The orbital cycles were the trigger, but they were not the bullet. Something else had to take that initial subtle cooling signal and amplify it. Something on the Earth itself had to hear the whisper and transform it into a planetary scream. The mathematics Milankovitch's elegant curves were perfect. They aligned with a stunning clarity. He had successfully mapped the rhythmic heartbeat of the solar system. But there was a ghost in the machine, a profound discrepancy that would haunt the theory for decades. When physicists meticulously calculated the actual loss of heat caused by these subtle orbital shifts, the numbers were, to put it mildly, underwhelming. Even in the direst scenario, the perfect storm of tilt, wobble, and stretch, the total reduction in solar energy reaching the Earth is remarkably small. It is equivalent perhaps to turning down a dimmer switch by only a tiny, almost imperceptible fraction. This should have caused a mild cooling, a few degrees drop in the Arctic, perhaps a slightly longer winter. It should not by any stretch of the imagination have buried North America under 3 kilometers of solid ice. It was a stark paradox. The orbital cycles were a whisper, but the ancient climate records screamed. The planet was reacting with a violence that the subtle solar input alone could not possibly explain. It was as if a gentle tap on the brakes had sent a car spinning violently off the road. This led scientists to a profound transformative realization. The Earth is not a passive rock. It is not a dead, inert ball of stone that simply sits in the sun and accepts whatever heat it is given. The Earth is a profoundly reactive system. It is a vast, complex machine with its own intricate internal gears, its own powerful levers, and its own hidden reserves of amplified power. The orbital cycles are merely the trigger. They are the key that turns the ignition. But the engine, the immense force that actually drives the full-blown ice age, lies within the planet itself. We call these mechanisms feedback loops. They are the intricate processes that take a small initial change and amplify it, doubling it, tripling it, until it becomes a runaway self-sustaining force. Milankovitch had found the rhythm. But to truly understand the deep freeze we had, to comprehend how the Earth took that subtle cosmic signal and with chilling efficiency weaponized it against itself. The planet possesses 2 great amplifiers, 2 powerful mechanisms that it employs to transform a modest cooling into a deep, pervasive freeze. One is made of light, the other is made of air, and the first amplifier works with the simple, elegant efficiency of a mirror. The first amplifier is built upon a fundamental principle of colour and light. Imagine walking across a dark asphalt parking lot on a blistering summer day. The ground beneath your feet is searingly hot. It radiates intense heat through the soles of your shoes. Now imagine stepping onto a patch of pristine white concrete. It feels noticeably cooler. This is the albedo effect. It is a quantifiable measure of reflectivity. Dark surfaces, the deep blue expanse of oceans, the dense green canopy of pine forests, the rich brown of fertile soil are hungry. They eagerly absorb the sun's incoming energy. They drink the light and efficiently convert it into heat, warming the air above them. A planet predominantly covered in forests and oceans naturally tends to retain warmth. White surfaces are the precise opposite. Snow and ice are nature's most effective mirrors. They do not absorb heat. Instead, they vehemently reject it. They bounce the incoming sunlight straight back up through the atmosphere and out into the cold, dark vacuum of space. A planet heavily covered in ice possesses a strong inclination to remain cold. This fundamental difference creates a dangerous self-reinforcing feedback loop. When the Milankovitch cycles align perfectly, when the orbit stretches and the tilt drops, the crucial summers in the northern hemisphere become weak, ineffective. A few persistent patches of snow, perhaps nestled in the Canadian highlands or the Scandinavian mountains, manage to survive through the brief warmth of July and August. At first, these patches are insignificant, tiny white dots on a vast, darker map. But these dots are powerfully significant precisely because they are white. They reflect the weak summer sun. The air immediately above them cools further. This localized cooling helps the snow patch survive and crucially encourages fresh snow to fall and accumulate around its edges. The white patch grows. As it expands, it acts like an ever-enlarging mirror. It reflects more and more incoming sunlight. The entire region surrounding it gets progressively colder. The colder it gets, the more it snows, and the more it snows, the larger and more formidable the mirror becomes. This is the ice albedo feedback loop. It is a potent, self-fulfilling prophecy of cold. Once the snow cover expands beyond a certain critical geographical point, perhaps covering the vast Hudson Bay or the Baltic Sea, the process becomes, for all intents and purposes, unstoppable. The planet effectively stops fighting the cold and begins to actively manufacture it. The great ice sheets of the northern hemisphere were not just frozen water, they were continent-sized shields of pure whiteness. At the height of the last ice age, the immense reflective whiteness of North America and Eurasia was bouncing enormous amounts of vital solar energy away from the Earth. The planet was in essence turning its back on the life-giving fire. It was actively rejecting the very energy that could have saved it from the deep freeze. This powerful mechanism explains how a seemingly small drop in incoming sunlight can trigger a profound local freeze. It perfectly explains the astonishing growth of the ice. But the ice ages were not merely local phenomena, they were global. When the north froze, the south froze in chilling synchronicity. The lush tropics dried out. The entire planet cooled in unison. A mirror in Canada, however vast, cannot by itself cool the dense jungles of the Amazon. For the cold to conquer the entire globe, the Earth required a second, equally powerful amplifier. It needed a way to transmit the chilling signal from the growing ice sheets to every corner of the world. It needed to fundamentally change the very air itself. The mirrors of ice perfectly explain why the North froze with such ferocity, but they do not by themselves explain why the entire world followed suit. When the vast glaciers marched relentlessly across Canada, the vibrant jungles of the Amazon also cooled dramatically. The immense deserts of Africa changed their character. The entire planet from pole to pole entered a synchronized global chill. A localized mirror simply cannot achieve this scale of global cooling. To fundamentally alter the temperature of the entire globe, you must alter the atmosphere itself. You must thin the planet's insulating blanket. This brings us to the second great amplifier, a silent thief. That thief is the ocean. To understand this profound mechanism, you need only consider a simple bottle of soda. If you leave a bottle of soda out in the hot sun, it quickly loses its fizz. The dissolved gas escapes rapidly into the air. But if you keep that same bottle ice cold, the gas remains securely trapped within the liquid. Cold water holds significantly more dissolved gas than warm water. It is a fundamental law of physical chemistry. As the Milankovitch cycles triggered that first subtle cooling in the high north, and as the white mirrors of ice began their work of reflecting the sun, the average temperature of the global ocean slowly yet inexorably dropped. And as the colossal volume of water cooled, it became hungry. It began to inhale. The ocean started to actively suck carbon dioxide out of the atmosphere. Billions of tons of this crucial heat-trapping gas were pulled from the sky and dissolved silently into the vast cold waves. As the CO2 levels in the atmosphere plummeted, the Earth's vital greenhouse blanket grew thinner. The planet lost its ability to effectively hold on to radiant heat. This in turn made the world even colder, which made the oceans colder still, which caused them to absorb even more gas. It was a relentless downward spiral into the deep freeze. But the ocean possessed another more active and biological way of burying the sky. It utilized life itself. As the immense ice sheets grew on land, they acted as colossal bulldozers, grinding the underlying bedrock into a fine, mineral-rich dust. This dust, laden with vital nutrients, was then caught by the fierce glacial winds and blown out over the vast nutrient-poor oceans. It acted as a massive planet-wide dose of fertilizer. The surface waters, suddenly enriched, exploded with life. Phytoplankton, microscopic plants invisible to the naked eye but collectively vast, bloomed in swirling immense clouds that could be observed even from space. These tiny photosynthetic creatures diligently absorbed the remaining carbon dioxide from the air to build their delicate bodies, and when they died, they did not simply rot on the surface, they sank. A constant, silent marine snow of dead carbon drifted down into the crushing darkness of the abyss. It settled upon the sea floor, locking that carbon away for thousands, even tens of thousands of years. The ocean had, with biological efficiency, effectively robbed the atmosphere of its critical insulation. This is precisely why the Vostok ice cores show that atmospheric carbon dioxide levels and global temperature move in almost perfect lockstep. When the CO2 goes down, the temperature crashes. The orbital cycles were the initial trigger. The expanding ice sheets were the powerful mirrors. But it was the ocean silently stealing the sky that truly transformed a regional cold snap into a global all-encompassing ice age. The trap was now fully set. The trigger, the mirror, and the thief had worked in profound unison. The world was poised for the long white winter. The trap was sprung. The trigger had been pulled by the subtle dance of Earth's orbit. The mirror of ice was now reflecting the sun's warmth in the ocean. The silent thief was burying the heat-trapping gases. Now the dramatic physical transformation of the continents began in earnest. We often imagine an ice age as a time of endless blizzards, a chaotic, stormy whiteout. But the growth of the great ice sheets was likely something far more quiet, and perhaps far more terrifying in its relentless inevitability. It was a slow, inexorable suffocation. It began in the high ground. In the Keewatin Plateau of Canada, in the mountains of Scandinavia, the snow simply stopped melting. Year after year, the layers built up 10 feet, 50 feet, 100 feet. At a certain critical thickness, the very physics of the snow changed. The delicate crystals at the bottom were crushed under the immense, unimaginable weight of the fresh snow above. They fused together, squeezing out every last pocket of air, transforming from white fluff into a dense blue plastic-like rock. The ice began to flow. It behaved like a slow-motion river of molasses or a vast viscous slab. Guided by the relentless force of gravity, colossal lobes of ice began to creep down from the highlands, spilling into the valleys, burying ancient forests and filling the beds of lakes. These were not the glaciers we see today, clinging precariously to the sides of mountains. These were true ice sheets, continent-sized domes that created their own immense topography. The greatest of them all was the Laurentide ice sheet. It grew to cover nearly all of modern-day Canada and the northern United States. It swallowed the Great Lakes whole. It buried the very sites of modern-day Chicago, New York, and Boston under thousands of feet of ice. At its centre, over what is now Hudson Bay, the ice was not a thin crust. It was a towering dome over 3 kilometres high. Imagine standing at the base of a wall of ice that stretched up into the stratosphere higher than the Rocky Mountains. It was a geological feature so massive, so profound, that it subtly altered the rotation of the Earth itself. It physically blocked the vital jet stream, forcing the high-altitude winds to flow around it, fundamentally changing the weather patterns of the entire northern hemisphere. In Europe, the Fennoscandian ice sheet descended relentlessly from the north, burying the British Isles and Scandinavia, its leading edge reaching all the way to what are now Berlin and Moscow. These were the white giants. They were heavy, cold, and utterly indifferent to the life they covered. They ground the surface of the Earth down to the bedrock, acting like colossal sheets of sandpaper, erasing ancient river valleys and carving out the very landscapes we walk on today. And as they grew, they did something else remarkable. They grew incredibly heavy, so heavy in fact that they began to subtly warp the very crust of the Earth itself. Water is heavy. Anyone who has ever carried a full bucket knows this. A single cubic meter of water weighs a ton. Now imagine a layer of water, frozen solid, stretching for thousands of miles, and stacked 3 kilometers high. The weight is astronomical. It is a burden so immense that the Earth's crust, the solid rock we think of as utterly immovable, could not withstand it. It bent. We tend to conceive of the ground beneath our feet as a rigid, unyielding platform. But on geological timescales, the Earth's crust is far more like a vast brittle raft floating upon a thick, viscous sea of molten rock, the mantle. When you place an immense weight on a raft, it sinks. Under the crushing, unimaginable load of the Laurentide and Fennoscandian ice sheets, the continents of North America and Europe literally sank. The solid rock was pushed down, depressed by nearly a kilometre into the Earth's yielding mantle. The ice in its growth created its own profound basins. It turned naturally convex landscapes into concave bowls. The Great Hudson Bay in Canada is a haunting ghost of this pressure. It is a vast depression formed by the very centre of the ice dome, where the weight was at its greatest. This sinking was not a rapid, sudden event. It was a slow, grinding surrender of the rock, and the recovery has been just as slow. This is the most haunting, enduring legacy of the Ice Ages. The ice has been gone for 10,000 years, yet the land is still remembering the immense weight it bore. It is still springing back a slow, patient exhalation. We call this phenomenon isostatic rebound. Right now, as you listen to this, the land in Scandinavia and northern Canada is steadily rising. It is lifting out of the sea at a rate of roughly a centimetre a year. The ancient beaches of the Vikings are now found far inland, lifted high, above the waves, by the slow, groaning recovery of the Earth's crust. The planet is still healing from the colossal bruise, but while the continents were sinking under the immense weight of the ice, the rest of the world was undergoing an equally dramatic transformation. The vast volume of water required to build these white giants had to come from somewhere. The ice sheets were not created from nothing. They were stolen from the sea. And as the ice grew, the global oceans shrank. The familiar map of the world was being furiously redrawn. To build a mountain of ice 3 kilometers high requires emptying a colossal portion of the ocean. The sheer volume of water locked up in the Laurentide and Fennoscandian ice sheets was staggering. It was enough water to lower the global sea level by a breathtaking 120 meters. That is the height of a 40-story skyscraper. If you were to stand on a beach during the last glacial maximum, the ocean would not be lapping gently at your feet. It would be gone. It would be a distant blue line on the horizon miles away across a vast, windy, salt-crusted plain. The familiar map of the world, the shapes of the continents we know from school globes, was profoundly erased. The British Isles were not islands. They were the highlands of a vast, low-lying European peninsula. You could have walked from London to Paris or from Amsterdam to Newcastle without ever getting your feet wet. You would have been walking across Doggerland, a rich grassy tundra, teeming with herds of mammoth and reindeer, a land that is now buried beneath the cold waves of the North Sea. In the East Asia and North America were not separated by the churning sea. The Bering Strait, that narrow strip of water between Russia and Alaska, was a wide, solid land bridge called Beringia. It was an intercontinental highway, a grassland corridor thousands of kilometres wide that allowed life to flow freely between worlds linking the disparate populations of the ancient globe. The planet was physically larger, its land masses more connected. The continental shelves were exposed to the air vast new territories for life to inhabit. It was a drier, dustier world. With so much water locked securely in ice, global rainfall plummeted. The lush rainforests of the equator shrank into isolated, struggling pockets, replaced by dry savannas. The world was not just cold, it was profoundly thirsty, and in this drained, expanded world life found a way. It did not merely endure the cold, it adapted. It used the new geography to move, to migrate, to expand. The ice had closed the northern routes for movement, but the falling seas had inadvertently opened the path for the greatest journey of all. The ice sheets were formidable walls. They were unscalable white fortresses that blocked the northern horizon, but in stealing the ocean's water they had inadvertently built vast bridges. For the diverse life of the Pleistocene epoch, the Ice Age was not a time of paralysis or stagnation. It was a time of unprecedented mobility, a grand migration across newly formed pathways. The world was colder, yes, but it was also connected in a profound way that it is not today. The isolation of the continents, usually enforced by vast oceans, was broken. The great land masses of Eurasia and the Americas, typically separated by the churning, freezing waters of the Pacific, were fused together by the Bering Land Bridge. But to call it merely a bridge is to diminish its true scale. It was a subcontinent, a landmass as wide as modern-day France, a lost country that existed for thousands of years before being drowned by rising seas. And it was not a barren, featureless sheet of ice. This is one of the great misconceptions of the Ice Age. We often imagine a world perpetually buried in deep, suffocating snow. But because so much of the Earth's water was locked in the colossal glaciers, the air was incredibly dry. In many places, it simply did not snow enough to build glaciers. Instead, a unique, now extinct ecosystem stretched across the top of the world. It was called the Mammoth Steppe. Imagine a grassland that stretched unbroken from the Atlantic coast of Spain, across the entirety of Russia, over the Bering Land Bridge, and deep into the Yukon Territory of Canada. A single, vast, windswept ocean of dry, highly nutritious grass and sagebrush. It was undeniably cold, arid and dusty. The wind never ceased its mournful blowing. But in the short, intense summers under the 24-hour sunlight of the high latitudes, this steppe exploded with biological productivity. It supported a density of large grazing animals that rivaled the African Serengeti of today. Herds of woolly mammoths, creatures perfectly engineered for this cold, dry world, grazed alongside woolly rhinoceroses. Massive herds of steppe bison thundered across the plains, relentlessly hunted by powerful cave lions and scimitar-toothed cats. It was a landscape of giants, a Serengeti of the ice, and following these immense herds moving quietly and intelligently through the tall grass was the most dangerous predator of them all, us. The Ice Age did not halt human migration. Indeed, it accelerated it. The lower sea levels exposed coastal routes, while green corridors that appeared between the ice sheets during brief warm spells acted as funnels drawing populations northward. For our ancestors, the Ice Age was not a barrier but an invitation. The drying of the world forced them out of shrinking forests and onto the open, resource-rich plains. The cold forced them to innovate, to master fire, to sew complex layered clothing, and to build sophisticated shelters. They followed the Mammoth Steppe. They walked from Siberia into Alaska, not knowing they were crossing between continents, simply following the life-giving grass and the abundant meat. They lived on the land bridge not just as transient travellers, but as settled residents for long periods. Genetic evidence strongly suggests that humans may have paused in Beringia for thousands of years. Beringian standstill, isolated by the immense ice walls to the east and west, evolving into the distinct genetic lineage that would eventually populate the Americas. The cold was a powerful forge. It tempered both the animals and the people, stripping away the weak, favouring the adaptable, the ingenious. For millions of years, this was the inexorable rhythm. The ice grew, the oceans shrank, the land bridges opened, and life moved. Then the ice melted, the oceans rose, the bridges closed, and life evolved in isolation. It was a perfect repeating pulse, a 41,000-year heartbeat that governed migration, evolution, and extinction. But then, about 1 million years ago, something strange happened. The rhythm broke. The cosmic clock skipped a beat. About 1 million years ago, the precise, predictable pattern that had ruled the Earth for eons suddenly shifted. The winters grew longer, the ice became thicker, and the entire cycle slowed down dramatically. For nearly 2 million years prior, the Earth had been a remarkably predictable machine. If you examine the deep sediment records from the ocean floor, the pattern is clear, rhythmic, and for its time unbreakable. The planet pulsed to a consistent 41,000-year beat. This was the cycle primarily driven by the Earth's tilt obliquity. As the Earth rocked back and forth on its axis, the ice sheets grew and shrank in perfect symmetrical sympathy. It was a world of balance. The ice ages were frequent, but they were relatively mild. The warm periods were frequent, but they were modest. But then, about 1 million years ago, something in the intricate machinery broke. This profound event is known to science as the Mid-Pleistocene Transition. It remains one of the most baffling mysteries in the history of our planet's climate. Without warning and without any obvious external cause in the celestial mechanics, the heartbeat of the Earth slowed down. It skipped a beat and then another. The clear 41,000-year cycle faded away like a distant echo. In its place, a new, much longer and much more brutal rhythm emerged. The dominant cycle stretched to 100,000 years. This was not merely a change in timing, it was a fundamental change in intensity. Under the old regime, the ice sheets were like shallow tides washing over the northern lands and then quickly retreating. But under the new 100,000-year regime, the ice became aggressive. It became stubborn. The vast glaciers refused to melt even when the tilt cycle indicated they should. They persisted through the warm orbital cycles. They grew thicker, colder, and immeasurably heavier, piling up for 90,000 years at a time, reaching heights and volumes that the planet had never witnessed before. And when they finally did collapse, the termination was violent and rapid, leading to the sharply serrated sawtooth pattern we observed in the Antarctic ice cores. Herein lies the true mystery. Here is the question that continues to keep climate scientists awake at night. The sun did not change its output. The Milankovitch cycles, the stretch, the tilt, the wobble, continued exactly as they always had. The cosmic clockwork did not slow down or alter its rhythm. The signal from space remained identical. But the Earth stopped listening. It stopped reacting to the strong, clear broadcast signal of the tilt and started dancing instead to the much fainter, much more subtle rhythm of eccentricity. It is as if a radio suddenly ignored the loud, clear transmission on its main frequency and tuned itself inexplicably into a faint, ghostly whisper of static in the background, amplifying it until it drowned out everything else. Why? Why did the planet decide to plunge itself into deeper, longer and more severe winters? Why did the ice become harder to kill? The answer, many believe, lies not in the distant sky, but beneath the ice itself. It lies in the intricate friction between the glacier and the underlying stone. The planet changed its skin. The answer to the profound riddle of the 100,000-year cycle lies in the very dirt beneath our feet. To understand why the ice became for a time invincible, we have to look at what it was sitting on. Before the deep ice ages began, the continents of North America and Europe were very different places. They were covered in a thick, deep layer of loose soil, finely decomposed rock and ancient sediment. Geologists refer to this as regolith. It was the accumulated dust and detritus of millions of years of patient weathering. When the first glaciers formed roughly 2 million years ago, they sat directly on top of this regolith. Think of loose soil as a layer of tiny ball bearings. It is inherently slippery. When the early ice sheets grew on top of this soil, they were highly mobile. They slid easily across the landscape. They spread out thin and fast like spilled liquid. And because they were thin, and because they were constantly moving, they were vulnerable. When the 41,000-year tilt cycle brought a slightly warmer summer, these thin, slippery ice sheets collapsed quickly. They melted away with relative ease. But glaciers are not just frozen water. They are the most powerful bulldozers in nature. Every time the ice advanced and retreated during those early shorter cycles, it acted like a giant relentless sheet of sandpaper. It scraped it, gouged it slowly, but surely pushed the loose regolith into the oceans. For 1 million years the ice was slowly, patiently stripping the continents naked. And then about 1 million years ago the colossal job was finished. The loose, slippery soil was gone. The ancient Canadian Shield and the Scandinavian mountains were scoured down to the hard crystalline bedrock. The fundamental physics of the ice changed instantly. Now the glaciers were no longer sitting on slippery soil. They were sitting on rough, high-friction stone. This dramatically increased friction meant the ice sheets could no longer slide easily. Instead of spreading out thin and wide, they began to grow upwards. They piled higher and higher, becoming thicker, steeper, and intensely colder. They became formidable fortresses of ice. Because they were so incredibly thick and cold, they developed a new profound resistance. When the 41,000-year tilt cycle came around again, bringing its promise of warmth to the planet, these new sticky, massive ice sheets simply ignored it. The summer warmth was no longer enough to melt such a towering fortress. The ice survived the weak heat and simply kept growing. It began to skip the beat. It waited. It grew for another 40,000 years and another until it reached a size so unstable, so massive, that only the most powerful alignment of all the 100,000-year eccentricity cycle could finally bring it down. The planet changed its fundamental rhythm because it changed its skin. By stripping away the soil, the Earth inadvertently built a profound trap for itself, allowing the ice to grow into the monstrous forms that defined the last 1,000,000 years. But even monsters have a breaking point, and when the 100,000-year cycle finally hits the end of the Ice Age is not a slow fade. It is a terrifying collapse. For 90,000 years the ice has built up. It is a slow, patient accumulation, a relentless subtraction of water from the ocean and heat from the air. But the end of an ice age is not slow. It is not patient. It is a collapse. In the precise language of paleoclimatology, this event is not referred to as a warming. It is called a termination. The very word implies violence, and it is entirely appropriate. When the 100,000-year cycle finally aligns for heat, when the orbit stretches back into a more circular form, the tilt rises to its maximum and the wobble points the North Pole toward the sun, intensifying summer insolation. The fortress of ice is attacked from all sides. The sun strikes with renewed intense fury. Carbon dioxide released from the warming southern oceans floods the atmosphere, thickening the greenhouse blanket. The ice sheets, now dangerously high and inherently unstable, begin to rot from within. They do not simply trickle away, they shatter. Vast lakes of meltwater, some the size of inland seas, pool precariously on top of the colossal glaciers. The pressure grows an immense internal force until the ice cracks, sending millions of gallons of water plunging down vertical shafts called moulins to the bedrock below. This water acts as a powerful lubricant. The immense friction that held the ice in place is suddenly destroyed. Whole sectors of the ice sheet destabilize dramatically. They slide into the ocean in vast armada-like flotillas of icebergs, a process known as a Heinrich event. These armadas are so vast they choke the North Atlantic, fundamentally changing the currents, altering the weather patterns of the entire globe. On land, the melting is catastrophic. Natural dams made of ice holding back trillion-ton lakes burst with unimaginable force. The resulting megafloods are beyond modern human comprehension. Walls of water hundreds of feet high tear across the landscape, stripping the soil down to the bedrock in a matter of days. The channeled scablands of Washington state are the haunting scars of one such violent cataclysmic release. And the ocean rises. It does not creep up inch by inch. It surges in dramatic periods known as meltwater pulses. The global sea level can rise by meters in a single human lifetime. The continental shelves are drowned. The land bridges of Beringia and Doggerland are swallowed by the relentless waves vanishing back beneath the sea. The map of the world is furiously redrawn. Islands are born from high ground. Peninsulas are severed. This is the Great Melt. It is the steepest line on the sawtooth graph. A 90,000-year winter is undone in just a few thousand years of chaotic, wet and violent spring. And when the water finally settles, when the ice has retreated to the poles and the coastlines have stabilised, a new world is revealed. A warm, wet and incredibly stable world. A world that would for the first time allow a wandering species of primate to stop running to plant a seed and to build a wall. The violent spasms of the meltwater floods eventually faded. The global sea level stopped their rapid ascent. The coastlines, which had been steadily moving inland for millennia, finally found their place in new equilibrium. And then, about 11,700 years ago, the Earth did something it had not done in a very long time. It settled down. For the previous 2 million years, the climate had been a relentless roller coaster. It was a chaotic, jagged line of freezing dips and feverish sudden spikes. The weather was an unpredictable, constant force of change. A human being born in 1 century might live in a lush grassland while their grandchildren might struggle to survive in a merciless dust bowl. But the new epoch, the Holocene, was profoundly different. If you examine the climate graph for the last 10,000 years, it is not a jagged line. It is almost perfectly flat. It is a plateau of warmth, a long, stable and golden afternoon in the tumultuous history of the planet. This extraordinary stability is the Holocene exception, and it is the single most important geological fact in the entire history of our species. Consider the precise timing. Anatomically, modern humans have walked this earth for at least 300,000 years. We have possessed the same complex brains, the same dexterous hands, the same innate capacity for language tool-making and invention for all that time. But for 95% of our existence, we built nothing permanent. We did not plant crops. We did not construct cities. We lived as nomads, small bands of hunter-gatherers, moving perpetually with the herds forever reacting to a world that stubbornly refused to stand still. We were intelligent, yes, but we were utterly at the mercy of the Milankovitch chaos. You cannot reliably plant a farm if the crucial rain patterns shift drastically every generation. You cannot build a durable city if the sea level rises a metre every decade. And then the Holocene began. The climate locked into a narrow, predictable range. The rains became reliable. The seasons became trustworthy. And almost instantly, everywhere around the globe, independently, humans stopped running. We planted seeds in the Fertile Crescent, cultivating the first grains. We cultivated rice in ancient China. We built monumental temples in the Americas. We invented writing, developed mathematics, and forged complex civilizations. Everything we are, everything we have built from the first mud brick to the International Space Station is constructed upon this single, fragile foundation of climate stability. We're quite literally the children of the Holocene, but when scientists look closer at this golden age, a subtle unease settles upon them. Because when they compare the Holocene to the previous warm periods, the other brief gaps between the ice ages, it appears strikingly strange. Usually the interglacial periods are short. They are sharp, transient peaks of warmth. The world warms up quickly, stays warm for a few thousand years, and then almost immediately begins the long, inexorable slide back into the cold. By all the established rules of the Milankovitch cycles, the Holocene should have ended thousands of years ago. The peak warmth has passed. The precise orbital geometry that caused the Great Melt has faded. The 65th parallel, that critical skylight of the Arctic, is receiving less summer sun. According to the cosmic clock, the party should be over. The ice should be returning. The glaciers should be creeping back down from Baffin Island and Norway right now. But they are not. The long summer continues, the pendulum seems stuck, and this leads us to the most unsettling question of all. Is this remarkable stability truly natural? Or have we, without fully comprehending the immense consequences, broken the clock? If we were to follow the strict, immutable instructions of the cosmos, If we were to obey the gravitational laws that have governed this planet for the last million years, our golden age, our Holocene, should be over. We are living on borrowed time. When astrophysicists meticulously examine the current orbital position of the Earth, the numbers are unambiguous. The intricate gears of the Milankovitch machine are turning decidedly towards the cold. The tilt of the Earth is subtly decreasing. It is slowly straightening up, gradually robbing the northern summers of their intensity. The wobble, the precession of the equinoxes, has moved the northern hemisphere's summer further away from the sun, reducing its peak warmth. The orbit itself is shifting. By every mathematical metric, the interglacial window, the natural period of warmth, is by all accounts closed. The critical solar energy falling on the vital skylights of the Arctic, specifically the 65th parallel north, is demonstrably dropping. In fact, the solar radiation in the Arctic today is almost exactly the same as it was 115,000 years ago. And 115,000 years ago was the precise start of the last ice age. So where then is the ice? The truth is, the planet did try to return to the cold. It tried to follow the ancient cycle. About 5,000 years ago, the peak warmth of the Holocene ended. The Earth entered a period known to geologists as the Neoglacial. It was a slow, stuttering slide downward into cooler conditions. The tree lines in Siberia subtly retreated south. The glaciers in the Swiss Alps and Norway woke from their slumber and began to creep slowly down the valleys, burying ancient forests that had flourished during the warmer times. This cooling trend reached its climax very recently in human history. We call it the Little Ice Age. From the 14th to the 19th century, the world shivered. It was a time when the River Thames in London froze solid, so thick that grand fairs were held on the ice. It was a time when the Viking colonies in Greenland, which had farmed green pastures for centuries, starved and vanished as the relentless sea ice closed in. It was a time of widespread famine and failed harvests across Europe, leading to significant societal disruption and geopolitical shifts. This was not a fluke event. This was the beginning. It was the first stumbling step down the long slope into the next glacial maximum. The planet was responding precisely to the Milankovitch signal. The mirrors of ice were attempting to form. The ocean was trying to inhale vast amounts of carbon dioxide. The system was working exactly as it always had. But then abruptly, the cooling stopped. In the blink of a geological eye, the trend reversed with astonishing speed. The slide into the cold didn't just halt, it shattered. The temperature didn't just level off, it rocketed upward with unprecedented force. The glaciers that had been advancing during the Little Ice Age didn't just retreat, they began to vanish at an alarming rate. The Arctic sea ice, which should be thickening right now, began to thin dramatically. The cosmic clock is still ticking. The gravity of Jupiter is still pulling. The axis is still tilting. The signal for winter for the next ice age is being broadcast loud and clear from the solar system. But the Earth is no longer listening. Something has jammed the gears. A new force has entered the intricate equation. A force powerful enough to override the immense gravity of the gas giants and the precise geometry of the Sun. And this force did not come from distant stars. It came from the ground beneath our feet. It came from the fires of a single species that learned how to unlock the ancient carbon of the Carboniferous period. The force that stopped the ice did not descend from the vast silent sky. It ascended from the deep hidden ground. For millions of years, the carbon of the ancient world had been safely buried. The lush forests of the Carboniferous, the teeming plankton of the Jurassic oceans, they had all been meticulously locked away in the dark, transformed into immense reservoirs of coal and oil. They were the planet's sleeping ghosts, patiently awaiting the slow, natural cycles of geology to one day return them to the atmosphere. And then in a geological microsecond, one species decided to wake them up. We call it the Industrial Revolution. But in the grand, timeless language of the Earth, it was a colossal carbon pulse. We dug up the fossilized sunlight of 300 million years of vast accumulated energy reserve and we released it back into the delicate balance of the atmosphere in the astonishing span of just 2 centuries. We took the planetary carbon cycle, a process that normally operates on the stately scale of millennia, and we accelerated it to the explosive speed of an instantaneous combustion. The effect on the delicate Milankovitch mechanism was profound and devastating. Remember the precise delicate balance required to initiate an ice age. The orbit subtly stretches to cool the Earth. The tilt gently drops to weaken the crucial summer sun, but these forces are inherently subtle. They rely on the atmosphere being thin enough, transparent enough to allow the excess heat to escape into space. Scientists have meticulously calculated a specific threshold, a magic number for the inception of a glacial period. To successfully start an ice age, the carbon dioxide levels in the atmosphere need to be consistently below 280 parts per million. For the last 10,000 years throughout the Holocene, we hovered right at that critical edge. The planet was primed. The door to the next ice age was slowly, inevitably unlocking. But then we began to burn. We pushed the number past 280, then past 300, then 350. Today we are pushing past 420 parts per million. We have not just nudged the planetary thermostat, we've effectively smashed it beyond recognition. The concentration of heat-trapping gas in our atmosphere is now higher than it has been for at least 3 million years, perhaps even longer. We've created an atmosphere that in its composition belongs to the Pliocene epoch, a time when the Americas were not yet connected and palm trees grew near the South Pole. This immense anthropogenic layer of carbon acts as a colossal shield. It intercepts the weak summer sun, traps its heat with relentless efficiency, and refuses to let it go. It completely overrides the subtle, natural cooling signal from the orbit. The gravity of Jupiter is still tugging, the axis is still tilting, the cosmic signal is still being broadcast, but it no longer matters. The natural signal is drowned out by the deafening noise of our own emissions. We have done something that no other species has ever done. We have cancelled an ice age. This is not a metaphor. Based purely on the orbital cycles alone, the Earth should have begun its slow, deliberate descent into the next glacial maximum within the next 500 years, perhaps even sooner. The vast ice sheets should be silently gathering their strength right now, expanding their reach. But because of the immense volume of carbon we have already emitted, that future is gone. The next ice age has been unequivocally postponed, perhaps for 50,000 years, perhaps for 100,000. Some scientific models even suggest that if we continue to burn all the remaining fossil fuels, we will not just postpone the ice, we will end the cycle entirely. We could push the planet into a state so hot, so far outside its natural rhythm, that the colossal ice sheets of Greenland and Antarctica collapse, completely removing the mirrors from the system forever. We have undeniably entered a new epoch. The Holocene is over. We are now living in the Anthropocene. This is the age where the dominant geological force shaping the planet is not the volcano, not the asteroid, and not the subtle influence of orbital mechanics. It is us. We have seized the controls of the planetary machine, a machine we barely understand. We have stopped the cosmic clock, but we have also jammed the accelerator to the floor, pushing the system towards an unknown future. We have bought ourselves a long extended summer, but the profound question remains what truly happens to a planet that is exquisitely designed to freeze when it is relentlessly forced to burn. We have purchased a reprieve, a long summer, an extended period of warmth. On the surface, this sounds like a monumental victory for humanity. After all, humanity is fundamentally a tropical species. We evolved in the warmth of Africa. We possess no fur, no blubber. We instinctively despise the cold. To have stopped the glaciers, to have prevented the crushing weight of the ice from burying our northern cities and industries, feels like the ultimate triumph of intelligence over geology, a testament to our technological prowess. But this perceived victory is a dangerous, seductive illusion. We have not just stopped the pendulum, we have in essence cut the cord that regulates it. And a planet without a regulating pendulum does not necessarily find a new balance. It often finds chaos. By pushing the carbon dioxide levels in the atmosphere far beyond the threshold of the last 3 million years, we are steering the planetary vessel toward a state that scientists call hothouse Earth. This is a world where the very feedback loops we discussed, the mirrors of ice and the oceans as carbon thieves, begin to work powerfully in reverse. As the Arctic warms, the white ice melts, revealing the dark, hungry ocean beneath. This dark water absorbs even more heat, which in turn melts even more ice, creating a self-reinforcing spiral. The mirror shatters. As the permafrost in the frozen north thaws, it releases vast quantities of ancient carbon and methane that have been locked in the frozen mud for millennia. The thief in this scenario returns the stolen goods, compounding the problem. The planet begins to amplify the heat just as efficiently and relentlessly as it once amplified the cold. If this trajectory continues, we are not looking at a stable warm Holocene. We are looking at a return to the Eocene, an epoch of profound warmth. Imagine a world perhaps only a few centuries or millennia from now, where the ice caps have vanished completely. Antarctica, the once white continent, becomes green perhaps. Forests of beech and fern grow on the shores of the Southern Ocean, just as they did 50 million years ago. The Arctic Ocean becomes a tepid, swampy sea teeming with azolla and algae. In this world, the global sea level is not measured in inches of rise, it is 70 meters higher than it is today. The familiar coastlines of the modern world, Florida, Bangladesh, the Netherlands, the great river deltas, become mere memories buried beneath the immense blue weight of the expanding ocean. But the true incalculable cost of this long-forced summer is not merely the heat or the water, it is the profound loss of the rhythm itself. The Milankovitch cycles, for all their inherent brutality, provided a script. They provided a predictable, oscillating stability within which ecosystems could adapt. The forests migrated north, then south. The animals adapted their ranges and behaviours. In the hothouse Earth, that script is burned. The weather becomes violent and increasingly erratic, fueled by the immense thermal energy trapped in the atmosphere. Storms become planetary in scale. Droughts become semi-permanent, devastating features of the continents. The ocean currents, those great conveyor belts that move heat and nutrients around the globe, may stall, or even reverse their ancient pathways, triggering further unpredictable changes. We have traded the orderly, rhythmic ticking of the cosmic clock for the unpredictable, feverish shaking of a broken machine. And yet the Earth itself, the rock, the water, the air, is profoundly patient. The carbon pulse we have released, while massive, is ultimately finite. The fossil fuels will eventually run out. The pulse will end, and then the deep, slow processes of geology will begin the arduous cleanup. It will take time, an almost unimaginable amount of time, 10,000 years, 50,000 years perhaps, 100,000 years. The silicate rocks of the mountains will slowly weather, reacting with the CO2 in the rain, patiently scrubbing the excess carbon from the sky molecule by molecule, and washing it back into the sea to be locked away in limestone and marine sediments. The fever will break, the atmosphere will be thin, and when the anthropogenic carbon is finally gone, the signal will still be there. The gravity of Jupiter will still be pulling, the axis will still be tilting, the sun will still be shining on the high Arctic. The Milankovitch cycles are not dead. They are merely waiting. They are the patient, eternal heartbeat of the solar system, waiting for the noise of the Anthropocene to fade so they can quietly resume their work. The ice will return. It may take 500,000 years, but the white giants will walk again. Because the Earth is not a static object. It is a living, breathing system, and we are just a momentary fever in its long, deep dream. Let us pull back. Let us leave the surface of the Earth. Let us rise above the smoke of the Anthropocene, above the melting glaciers, above the noise and clamour of our civilization. Let us travel out into the quiet blackness of space, to a point where the Earth is just a marble of blue and white suspended in the infinite void. And now let us speed up time. If we were to watch the last 1,000,000 years of our planet unfold in a time-lapse, we would not see a mere rock. We would not see a static, unchanging map. We would see an organism. We would see the great white cap of the North Pole flowing south like spilled milk swallowing Canada. burying Europe, turning the entire planet white, and then we would see it shrink, slowly pulling back to the sea, revealing the green and brown of the land once more. Expand, contract, expand, contract. It happens rhythmically, predictably, once every 100,000 years. It looks exactly like a chest rising and falling. It looks like a lung filling and emptying. The ice ages are not a disease. They are not a mistake. They are the profound respiration of the planet. For the last 1,000,000 years, the Earth has been breathing. It inhales the cold, and it exhales the warmth. It draws the ocean onto the land as ice, and then releases it back as liquid water. This rhythm is the very pulse of the solar system itself. It is the gravity of Jupiter tugging at our orbit. It is the gentle nod of the axis toward the sun. It is the silent silver machinery of the cosmos driving the deep breath of our world. And we are the creatures of the exhalation. We have built our cities, written our histories, and lived our entire collective existence in the brief warm pause between two immense breaths. We are the children of the interglacial. We assume that the summer is eternal simply because our lives are so short, so fleeting in this cosmic timescale. But the Earth operates on a fundamentally different timescale. It does not measure time in years or centuries or even dynasties. It measures time in cycles, in wobbles, in orbits. The silence of the Earth is not an emptiness. It is a profound patience. It is the patience of a mountain waiting for the ice to return and grind it into dust. It is the patience of the ocean waiting to reclaim the shore. It is the profound patience of a planet that knows with mathematical certainty that the winter will come again. The carbon we have pumped into the air is a disruption. It is a fever, but it is temporary. The rock will absorb it, the ocean will hide it, and eventually the fever will break. And when it does, the great gears of the sky will still be turning. The wobble will still be shifting the stars. The orbit will still be stretching into the dark. The signal will still be there, clear and resonant, and the Earth slowly, peacefully will begin to inhale once more. So as you lie here tonight, safe in the warmth of this long, beautiful summer, remember the rhythm. Listen to the silence. It is not the silence of the dead. It is the deep, steady, and eternal breathing of the world. Good night.